It's my privilege to introduce our esteemed resource person for today's session, Dr. P. Chinnaya, a distinguished academician and researcher in the field of electronics and communication engineering. He is currently a professor in the Department of Electronics and Communication Engineering at St. Joseph College of Engineering, Sri Perumbudur. He holds a B.Tech in Electronics Engineering from the prestigious Madras Institute of Technology and an ME in Medical Electronics from Anna University College of Engineering, Guindy campus. He further pursued his PhD in a study and application of medical standards in a collaborative healthcare information system from Marina University. With an illustrious career spanning over 25 years in teaching, he has served in key leadership roles, including head of the department, for more than 12 years and register of St. Joseph University, Nagaland. His research interests lie in medical informatics, medical standards, e-health, and medical expert systems. A prolific researcher, he has published and presented over 50 papers in reputed national and international journals and conferences. Additionally, he has authored 2 books and 2 conference proceedings and holds an impressive 5 patents to his name. He is also an active life member of Aicte and ISTE, continuously contributing to academic excellence and professional development. His commitment to lifelong learning is evident as he has recently earned multiple NPTEL online certifications in NBA accreditation and teaching learning engineering, deep learning, digital image processing, and neural networks and security. A passionate educator and speaker, he has delivered numerous invited seminars on various cutting edge topics, inspiring many in the academic and research community. And we eagerly looking forward to gaining valuable insights from his expertise. Now I request our resource person to take over the session.
Good evening, all. I'm happy to welcome all the participants to attend this session in IoT in e-health. We all know that e-health is nowadays very important, and the technology changes have made great changes in the healthcare domain. So with this in mind, we will see some important things which have the access technologies, the ancillary technologies which are helping the e-health improvement, interoperability, and issues as feature scopes. All these things we'll discuss. First, before going to the IoT in e-health, you will see what is e-health. The e-health refers to the use of digital technologies such as internet, mobile devices, and electronic systems. These technologies improve the healthcare services and also enhances the management of health information and enable more efficient and accessible healthcare. The benefits of e-health are increased access to patients who are in remote villages and unreachable isolated places. Other benefit is improved patient care. The patient can be connected with the technologies. His conditions can be continuously monitored. It is another important aspect. Coming to the cost efficiency, because the patient need not to go to the hospital for even a minimum minor checkup to major some kind of routine checkup, he can directly contact the healthcare providers or healthcare personals by sitting at home. by sitting at his office, wherever he is there. If the person is on move or for some tours due to his hectic schedule, and the cost regarding the transport and other expenditures will be minimized. Better coordination of care is maintained because the care health, there is a direct contact between the patient and the healthcare providers and the healthcare supporters. Often whenever they want to have online contact and email contact, and they can send informations through technologies available today. These are the some of the benefits of e-health. Now, the present hostile environment is like this: when the patients go to the hospital and wait in a long queue, in the absence of e-health technologies or in the absence of modern technologies used in any hospital environment, the patients have to wait for a long time in the queue, which makes much difficult for the healthcare providers as well as the people who go for taking care. In order to avoid this, we go for the connectivity of healthcare to the patients through the technology called Internet of Things. Before going to that kind of connectivity, we'll see, we all know that Internet of Things refers to the network of physical devices which are used to collect, exchange, analyze data over the internet. In e-health, the IoT devices are used to monitor, manage, improve patient care in real time. And IoT is revolutionizing healthcare by enabling smarter and more efficient and personalized care through the use of connected devices and sensors. Such a technology has also some challenges when it is to be offered to the entire people, the entire community, either in the nation or in the worldwide or any uh, small community services. Major challenges are data privacy and security. When the healthcare when the data is sent or when the data is stored in a particular place, whether it is in a healthcare uh, provider's place or somewhere where the data is stored in repositories, there is always risk for the security and privacy of the data. And the digital divide is another one where this technology could not be taken to all the places in where the places are very remote, where you cannot use the digital technology because we don't have much communication facilities, and which needs a large amount of investment for healthcare provider sectors. So if healthcare sector is to be installed in a place where or established in a place where small number of people are there, where density of people is less, it is very difficult to spend a large amount of money. So this digital technology could not be used for entire people. And other important issue is regulatory issues. Every country, every place, or every organization, every region have their own regulatory issues. They will give this kind of certain kind of limit. They will provide certain kind of limitations which prevents the invasion of this technology beyond the region's boundary. Integration with the traditional systems. Almost most of the hospitals or healthcare providers have equipped with some kind of equipments with the the previous technologies. By investing more amount of money, but now it is very difficult to either to integrate this new technology with the equipment or make that equipment be replaced by new equipment. That is another problem integration with the traditional systems. Now, with all these things, we see the current market of Internet of Things in healthcare is, you can see that it is 44.21 US billion in 2023, as it is expected. Now it is expected to grow. Actually the growth of compound annual rate is going to be of 21.1% from 2024 to 2030. So this will possible because of increase of adoption of remote patient monitoring for patient for improved outcome, right, of the hospital uh, performance. Coming to the Internet of Medical Things market in 2018 to 2030, if we see that graph, we can see an exponential growth from 2018 to 2000. There's going to be, now itself it's an exponential up to 2025. Now it's a steep, the increase is very steep, right? That actually in the year of 2030, it is going to be reach, it is 30.6 million US dollar, right, in the to the in India. Indian telemedicine in the medical IoT applications. Now, with this, we go for the various divisions of e-health. The e-health, we know that is a digital technology which uses digital devices to offer healthcare services by using modern equipments. It is divided into various sectors like health informatics, electronics health records, that we call it as a EHR, telemedicine. Again, telemedicine is divided into teleconsultation, telesurgery, teledentistry, telepsychiatry, teleradiology, and cardiology. Coming to the health, the mobile health, right? It is modern technology which everybody using. We will see that also. Now, computerized physician order entry is another area which comes under e-health. The another area which comes under e-health is e-prescription. It's nowadays, right, it's with the seamless integration of the equipments with advanced technologies with the 6G, right? It is very possible for online prescriptions and online the direct consultation with the patient by the physicians, health or healthcare providers. Now, coming to the e-health, now we see that e-health combines telehealth and telemedicine. The telehealth and telemedicine is the direct actually the video conferencing methods are consultancy by the patient to the medical service provider or doctor. It is a dedicated service. Coming to the telehealth, it offers additional supporting services apart from telemedicine, right? The telehealth also gives the education to the masses. It also talks about such kind of additional services. It combines telehealth. So there is so it means that telehealth is telemedicine is one part of telehealth, and e-health, right, have the key aspect of telemedicines are remote consultations, specialist access, convenience, diagnosis and treatment, chronic diseases and management, and chronic disease management and urgent care. Coming to the remote consultation, as we had said that doctors can give advice or can give prescription to or can know about the patient's condition by sitting anywhere in the world to a person sitting anywhere in the world. And coming to the specialized access, the patient can have a continuous access or can have a specialized care by the physician whenever they want to have online meeting or discussion through the technology. It is very convenience as some of the convenience like, right, and need not to travel, and it is a timely consultation. It is immediate remedy, possibility for immediate remedy is possible. And the diagnosis and treatment, the diagnosis of the patient can be possible if the patient sends his record of ECG or any records he has taken from his biological system, or can be sent to the doctor, and the doctor can suggest the remedial treatment measures. The chronic disease patients who are suffering a lot for long time could not move from one place to another place, or could not meet the service healthcare providers, can have an online consultation, and it will support for the treatment of such a long term the disease, in case of a patient having long term diseases. And urgent care, if someone is having a problem or some kind of issues like heart attack or any kind of these things, the immediate care can be obtained from a doctor known, right, or any healthcare provider or healthcare health practitioner or doctor can advise the particular person to take immediate care or urgent care regarding the situations. Now, coming to the types of telemedicine, there are two types of telemedicines. One is synchronous telemedicine, other is asynchronous telemedicine. In synchronous telemedicine, both the doctor and the patient are directly they having direct contact in real time. Real time. So the doctor can ask the patient about the condition, about his condition, and he can see his records online. He can see various, suppose the data is being collected currently. That data can be seen by the doctor immediately, and can give the advice advice for treatment. And another one is asynchronous type of telemedicine, where the patient can send his data to the doctor. The doctor will check the data and give the kind of treatment the patient has to take or undergo, right? That is not real time. It is communication, which is something apart from the real time. And coming to the key aspect of telehealth, as we have discussed, it is very convenient for remote monitoring, and we can have the patient can have a direct contact with the doctor at any time he wants to have, without moving from his place. Healthcare education, the patient can have a healthcare education through the telehealth. As we have said that the healthcare providers will offer some supportive services to make the patient to take care of his health or her health, right, by making certain kind of, by following certain kind of habit, just like a exercise, just like a reading books, just like make you doing some kind of work. These things can be advocated to the patient. Mental health support, the telehealth can give the mental health support to the patient who are not able to move, and they are having a long term kind of long term problems. All these things can be solved. And coming to the administrative services, it can help, it can support for administrative services. The doctor can give certain kind of advices on to particular organization or particular patient or any kind of thing. And public health services are possible because of the telehealth, since as we said that the patients who are in the remote areas need not to come to the city hospitals where sophisticated equipments or facilities are available. The doctor, an expert sitting in the city, can give his advice or his service, provide his service to a patient sitting in the remote areas or villages. And another important thing about the examples of telehealth services, right, remote patient monitoring, virtual therapy and counseling. So therapies and counseling can be done virtually without meeting the doctor. The patient can have it without meeting the doctor, and virtual follow-up after the treatment can also be possible. And health education on webinars can be conducted through the telehealth. And benefits of telemedicine and telehealth are increased access to care, convenience, cost effective, continuity of care, fast access to care, reduced risk of exposure to infectious disease, their emergency circumstances like COVID, or any region where most people are affected by some kind of communicable diseases, they need not to go to a hospital where large crowd is there. So where in such a good situations, the patients can have a telehealth services, can avail the telehealth services, and can take a treatment. And the challenges of such a fantastic technology, which provides all kind of services, sophistications, and provides less amount of fatigue, less amount of cost, and more convenience, will also have some challenges in its implementation. The technology barriers, as we have discussed, the technology, right, must permit such kind of services, because countries like India, which are developing, then may find much difficulty in providing such kind of telehealth services to the people who are in the remote areas. And regulatory, as we have discussed, privacy and security are other important challenges. Quality of care concerns, when the patient, when the doctor gives telehealth the services, provide services to the telehealth, he may not be able to meet the patient in person. Sometimes the patient may not be able to tell or give the real conditions, the time the quality of care concern occurs, and limited scope for certain conditions. These are the certain things regarding the challenges of the telehealth. And feature of telehealth and telemedicine are, as the technology advances, new communication technologies emerging, artificial intelligence and machine learning are going to support a much, are being started to support much in healthcare services. Along with this e-health, the patients can have a very good treatment, and can have the community, the society can have a very good medical facilities or healthcare facility, avail healthcare facilities. Such scopes, the scope and the impact of telemedicine and telehealth are expected to expand significantly. The key trends include, as I said, the integration with artificial intelligence and big data. We know that the AI could give a best type of suggestions to the doctors. The doctor can get a suggestion from the particular AI system which they use. It will assist the doctor to make his assessment, or to make sure his assessment is right. And big data, because of the big data, the data storage and data transparency is more, and it is very convenient. And coming to the expanded remote monitoring, so because of the cloud applications, IoTs are there and e-health is are there, so this remote monitoring can be expanded, right, to entire region of the world. Virtual reality and augmented reality, AR, VR is providing more value to the healthcare support, because the VR and AR support the examination of various images, or the body inner part of the conditions of the inner part of the body, right, by using AR and VR. And the global expansion, so because of the artificial intelligence and big data and AR, VR, all this, the telehealth services and telemedicine services can be augmented globally, or can be expanded globally. Now, coming to the feature of telemedicine and telehealth, the integration of, as I said, AI with the big data, right? The AI can assist with the diagnosis, providing decision support to healthcare providers during telemedicine and teleconsultations. So the big data is a central part of all these areas like telemedicine, population health management, drug discovery and development, real-time allerging, electronic health records, genomic sequencing, remote monitoring, predictive analysis. All these things can be clubbed together along with big data analytics, and the accurate services, care, or prediction analysis can be done by using this integrated environment in healthcare. The future of telemedicine, telehealth, or nothing but as it is said that everybody will have the electronic, the e-health portability, compatibility of e-health portability. People will have expanded care, the devices that will track more aspects of health, including wearable sensors and implantable devices, will allow for more proactive health managements. So the healthcare managements will improve to better in a better condition than it is now by in future, because of the 6G technologies and other AR, VR, along with big data is emerging, or day by day it is showing its contribution in the field. The future of telemedicine and telehealth are virtual reality and augmented reality. Those two technologies assist the doctors not only as for the better treatment, but also the AR, VR assist the doctors to learn about the body, the physiological system, the human body, by using these technologies. So that's a real time. It's a wonderful technology which assists the medical practitioners during their training period, or when they go for any kind of special advanced technology or advanced treatment procedures. And the future of telemedicine and telehealth globally is going to increase in 2032 about 590.6 dollar US 6 US billion US dollar in 2032. Right after, we can see after COVID, right? We could see the increase of telehealth services and telehealth. There are two things here. One is telehealth services, and other is a telehealth product. We can see in the bottom, the thick blue shows the telehealth product, while the upper part of that vertical graph shows the services. Now we can see the increase of the telehealth services are more than the increase of the telehealth product. It means that the globally the people need, or the world need, more number of contributions from the engineers, contributions from the researchers, contributions from the government to increase the product, to offer more services to the people, because services are more and the products development are very it is slowly increasing. So that is the thing. So this telehealth technology and the e-health and the medical side research, right, will provide more opportunity for younger generation, new generations. And coming to the next part of this telehealth, the e-health technology is electronic health record. Electronic health record. See, any patient, when they go for a hospital, they are given a prescription, they are given the treatment plan, or they are taken all kind of tests, and all are recorded in a text, in a paper. But all these things are now replaced, right? It is given as a digital version. So the e-health records are digital versions of traditional paper-based patient charts. The e-health electronic health records are an essential component of modern healthcare, offering a more efficient and secure way of managing and sharing patient health information. For example, a patient has met a doctor yesterday in one state, right? A capital of one state is in a capital of another state around 500 kilometers or 1,000 kilometers away, right? The patient's data can be immediately acquired from the previous healthcare organization from which the patient had already taken the treatment. So it is one of the wonderful thing, right? The patient data can be either stored in a repository, or it can be taken from any healthcare organization, or the patient can have its own electronic health records. So this is the one of the wonderful type of supporting part for the healthcare providers and the healthcare takers. The key features of this electronic health record are comprehensive health informations. The patient can have his own history. There is entire history of the patient. The entire history of the patient can be in the healthcare record. The paper need not be wasted. The paper will not be torn, or they cannot be damaged, or patient need not to forgive anything. And this is the one of the thing. And coming to the real time access, that suppose a patient is in a remote hospital, the data is in a particular place somewhere else, the doctor can see it. Or the patient and the data is in a remote one hospital, the doctor is in somewhere else in another hospital, the data of the patient can be seen by the practitioners. Interoperability, so it means that the data can be right. Now the interoperability is one such a limitations, then because the technologies are of different, so the interoperability issues will be solved, right, because of the continuous efforts taken by various organizations, international organizations, related to industries, related to government, related to service organizations, right. The various standards are available to meet the interoperability of various aspects like e-health record, electronic health records, and standardized formats. So here also we will be see some of the standardized methods in the next slides about formats. See anything for anything, we need a standards. That's what we talk about. A standard format means the data can be filled. When the format is available, a file format is available, the data can be stored in the file format. It can be retrieved anywhere else when the standards becomes now we can see even in our computer systems we have standard. Any device can be plugged out from where and somewhere and can be fitted somewhere. It was not possible in those days. There were lot of problems, but now standardization is coming in all fields. Likewise in healthcare also, more standardization is going to standard formats are emerging. The decision support tools, right, it will also right provide more supports for by using different supporting tools. Patient portals, the patient can have his own portal and open by his own password and username, and can see his data, what the doctor told anything, or has doctor given any advices, or doctor has given any appointment when it is expected, when it has been requested for that. Secure data storage, and the data storage, right, that is very easy because there are a lot of digital technologies are available in a standard formats. It can be stored and it can be used whenever it is required. Benefits of electronics records are improved patient care, accuracy and completeness, better coordination of care, efficiency and time saving, as we have discussed in the previous slides, better patient engagement, the cost savings, improved decision making because of the availability of the entire data with the doctor about the patient. The challenges of it, there are some challenges about creating the interoperable health records, or cost of implementation to everywhere, to all the places, to make every hospitals, to make every healthcare unit, to connect every citizen, every villages, every country or every state is even for it is very difficult for a state government or central government or any region. Interoperability, as we have discussed, it is being addressed now. Now the data security and privacy, another thing, and usability and training, right? So even when we have modern equipments, because of these technologies, which comes with a lot of procedures, the training the healthcare supporters like technicians or doctors, right, is very difficult nowadays, right? We need to give a training and data overload, because large amount of health data is coming emerging every time. Hospitals must plan but in a better way for storing the data. Otherwise, it will create a lot of confusion in the hospital environment. For that, they need some kind of unification code or some kind of segregation of data, patient wise, area wise, the disease wise. All these things are possible. The future of electronic health records are because of artificial intelligence and machine learning. The electronic health records is going to have right much more advantages, or is going to be much more advantages to patients or healthcare providers, because all the informations can be stored in the electronic health record. No need to take any separate printout or something else. And coming to the increased interoperability, as we have discussed, like every technology develops, the interoperability also simultaneously right being addressed, and more commonality and the easiness in exchanging the data from one entity to another entity is becoming reality now. Patient care centric electronics health record is going to be, because the patient has its own data and he has access to the data, and everything is given to him clearly, and he can see his conditions and he can adjust his lifestyle and treatment plan, and even certain kind of decisions can be taken based on the data. The blockchain for data security, right? Blockchain for data security is another main advantage of security about the patient data. The patients, right? The data is very precious and it should not be shared with anybody else. So it is very important, right? Technology which assists the healthcare providers and the patients. Now coming to the mobile health. The mobile health refers to the use of mobile devices such as smartphones, tablets, and wearable devices and associated applications to promote health and prevent diseases, manage chronic conditions, and improve healthcare delivery. The mobile health, right, components have some applications, and these apps are nothing but the software to help individuals manage their health, right? With the devices or equipments or technology available with them. These apps may focus on health tracking of the patient. For example, diabetic patients can track his glucose level and all these things. Medication reminders, right, can be possible by various softwares which will remind the patient of various kind of precautionary measures or treatments or the medicines they have to take. Chronic disease management, the continuous monitoring of the patient, right, is possible because of the mobile app. When the patient is either moving or somewhere else, or not in the hospitals, or not able to move to the hospitals. For mental health also, it supports people suffering with mental health in their own places. Telemedicine and virtual care is another important aspect of this mobile health, right? Because the patient or the people can be able to have advices or take treatment by sitting on their own place. Now coming to the US M-Health markets size, from 2015 to 2026, it is increasing right rapidly, and we can see that various areas like for like fitness, nutrition, diet, women's health, healthcare providers and players, lifestyle management, disease management, medication adherence, and others. All these things are right every year, right, that it is increasing. Now coming to the wearable devices and mobile apps, we have various wearable technologies, right, such as fitness, right, for various kind of applications such as fitness trackers, smart watches, and health specific devices, right, can be used for continuous glucose monitoring or ECG device or ECG, right, can be monitored and can collect real-time health data and sync with the mobile apps, and the patient can himself can have a data on his he can see his data the condition, so he can be given advice, right, about his own health conditions. And coming to the wearable devices and mobile apps, examples of wearable devices include, right, there are fitness trackers, for example Fitbit, Garmin, they track the physical activity like steps, exercise, heart rate, right? All these things, including sleep patterns, can be recorded by these fitness trackers. Apple Watch and Samsung Galaxy Watch can track the activity monitor active the can track the activity of the person or monitor the heart rate and detect the anomalies, for example irregularities, rhythm in the heartbeat, and can also be, right, tracked, and it can be integrated with the other health apps, right, and apps, and the particular conditions can be analyzed. Medical wearables devices like continuous glucose monitors for diabetics and wearable ECG monitors for health uh, can be included in this. The remote patient monitoring can include some of the blood pressure monitors, blood glucose meters, wearable ECG monitors can be used, right, in the mobile technology, where the patient need not to go to hospital, and all these measurements can be taken, right, from their own place itself. And telemedicine, telehealth, right, supports health and wellness platforms, or with wellness platforms. Examples like MyFitnessPal, Headspace, or Calm, Garmin Connect, or Apple Health. These platforms supports the wellness of the patient. And coming to the health gamification, there are apps like Zombies Run. These apps will make the patient to be unfatigued, right? When the patient use these apps, they will forget about all the tensions, and when they are making some kind of fun activities, right? Then the conditions will improve. That is the one application of this mobile app. Benefit of mobile healthcare, right? Health is there are many benefits like improved health monitoring, increased access to care, cost savings, empowered patient, better chronic disease management, enhanced communication. So all these things are possible because the technology is in their side or in their hand. And coming to the challenges of such a wonderful technology or data privacy and security, it is always a problem when you go for the things like wireless. A lot of wireless technologies are available. Data can be breached, data can be taken by somebody else, and these data, right, are very precious, right, and it cannot be compromised. The devices and app reliability. Sometimes the device which supports which are used for measuring or calculating certain things may not have accurate data. It means that it cannot measure accurately. There may be some issues as like trainers, or like the sensor could not be properly attached to the patient, or the sensor may malfunction. These are the certain things which may give a wrong data. The user adoption and engagement, the user adoption. So actually the patient the must have that people may be afraid of taking certain kind of technologies, fearing of certain side effects. Limited access to technology, other that is one thing. These technologies may not be available everywhere. That is a common problem in respect to all the emerging technologies. And regulatory and legal issues, as is that every country or region or organization puts in their own legal and regulatory conditions which have to be followed when a thing is to be implemented for manufacturing or providing support to the patient. or the future of M health, the mobile health is going to be the integrate. It is integrating with the machine learning and artificial intelligence, because of it, the patient will have the healthcare people, the healthcare taker will have a more advantages, more accurate result supported by AI in machine learning. Expansion of telemedicine and virtual care, right, is possible because of mobile health technology. The communication technology will take them this particular facility, M health, to everywhere. Wearable technology, the increase of wearable technology will also increase the wearable health technology, and people will have sorry, more facility from this kind of M health. And personalized medicine and precision health is possible because of M health. The doctor can advise the patient, right, and can contact, right, at any time, and can advocate the patient to have a continuous, or to take steps can be advised to the patient. Improved interoperability and integration. Nowadays, this mobile technology, the data can be integrated to everywhere. So now it is because of the communication wireless technology, right, makes it possible. Even now, WhatsApp, which we are using in a computer, in a mobile phone, is being used in right. The same thing is used in a desktop or a laptop, or whatever we use here, right, in our the technology which is in our hand can be used with the technology which is available in an establishment and a place, right, as it is kept in a particular station. And coming to the other important thing about health information exchange, as we have discussed health information, the health information now is available as electronic health record. It is available as a digital. It is not a paper. This the exchange of this data between various entities, between various organizations, refers to electronic sharing of healthcare related information among different organizations or entities such as hospitals, clinics, laboratories, pharmacies, and public health agencies, right, can have the continuous, the seamless exchange of data. This particular process is called health information exchange. The health information exchange is possible, right, between any two organizations, or among all the organizations, because of the health information exchange. And coming to the concept of health information exchanges, it is nothing but exchange of data. The data is nothing but the health data of the patient. It is exchanged, right, in the electronic health as electronic health record. This electronic health record should have the interoperability. Interoperability is to be made, right, ensured. Then only the data can be exchanged from one entity to another entity. Suppose there is a laboratory system and there is a hospital information system. The information should flow between these two information, even within the same campus, or the same entity, same healthcare service providers may use different sectors or areas. The data, right, acquired from a laboratory information system must reach the hospital medical information system, where the doctor will be sitting and looking into the data taken for any patient at the laboratory. This particular health information, right, exchange offers a much benefit, right, by improved patient care and safety, and complete and accurate informations, because of the data is available in digital form. Reduction of medication error, because of the data is available, right, readily, and a lot of technologies are being used. The chances of error in deciding the things will be reduced, and better coordination of care is also possible, because the patient and doctors could have data on both sides, right? And the patient can also see his own data and tell the doctor what is the condition. This is the possibility. And coming to the efficiency and cost reduction, because of the data, taken at one aspect of on a from a person at one entity need not to be repeated in another entity and another healthcare provider section. So they can, that same data can be used, that same data can be used, and it can be used as a mood for the patient, because the efficiency, the time taken for recording the data and the cost involved is the cost reduction is also more. And this particular the efficiency involves avoiding the duplication of test data and reduced administrative burdens, decreased hospital readmissions. As I said, that the data need not be taken again and again. The patient need not to go to the laboratory information system again to take the data, and duplication of the test will be avoided. And the next is enhanced public health monitoring. Because of the health information system, it improves disease surveillance and better reporting. Because of the data is available readily in the digital form, all these all these services can be readily availed. The patient empowerment is possible because of the patient is capable of accessing the healthcare information about health information and the shared decision making. The patient and the doctor can discuss with each other, and the doctor can a particular doctor can discuss with a doctor in another entity, or with the expert in the same area, and a better decision can be taken. It also supports for research and clinical trials. So because of the large amount of data are available as a digital in a digital form, these data can be analyzed for any health conditions, for any developmental activities, or for any factor. This research becomes very easy because the data is available. The researcher need not to go for research searching data anywhere else, because it is available right readily. Types of health information exchange models are centralized health information model, decentralized health information model, hybrid health information model. The centralized health information model, where all the data will be stored in one particular place, where in decentralized, right, the data can be stored in different places, and hybrid combines both centralized and decentralized. Coming to the challenges of the healthcare information exchange, even though it offers more facilities or it has more features, there are challenges in implementing this, like data privacy and security. When the data is stored in a healthcare sector or any repository, it is possible for the theft of the data, or anybody can misuse it, or the data can be erased, right, completely, or something is missed, and that is another thing. Security is another important problem, and complaints, and the researchers can work about the work on these areas and find more suitable solutions to improve the patient condition, to improve the service provided to the society. And interoperability issues and cost and funding also is important. Whenever we go for high technology, it involves more amount of investment, right? And it has a huge interoperability issues as to make it to work along with the existing equipment. Existing equipments are having less capability, bandwidth, less communication capabilities, less memories, and less accuracy. All these things, right, are the main thing. And because of this, the funding is becomes a very important issue, and adoption to resistance to adoption of this technology. A government or a organization or a center or a society needs to adopt for a change from one technology to another technology. Now coming to the data quality and the standardization. So any data, because of emergence of various data collecting centers, data quality is to be maintained. The standard data should be recorded in a standard format. The data recorded in a standard format only can be transferred to another entity as a readable or retrievable information. It's very important for storing the data in a format which is retrievable in any other system or by anywhere else with a permission, right? That is what the quality of the data also is very important in digital technology. Change of any particular, right, thing like 1 bit, 0 bit, like that, right? It can also change, like when it is related to image data, it's very important. Now coming to types of health information in exchange of this, and direct exchange, query based exchange, consumer mediated exchange, health information networks. So these are the types of health information exchange, and some examples are regional health information organizations, state-wise health information exchanges, the nationwide health information exchange. So where all these information exchanges are possible, because the patient, a particular state hospital can be connected with all rural hospitals, or a district hospitals can be connected with all municipal hospitals, so that patient can take a data in the municipal center, the laboratory our laboratory in a village, and the data can be sent to the central repository in the central storage place, or information storage place in a city, and the doctor sitting, especially sitting in a city hospital, can see the data thing, or the information available in the data, and give the medication or treatment advices to the patient through the e-health portal itself. Now, next is fifth, the health apps and wearables. These health apps and wearables are revolutionizing personal health management. Because of the technology available in our hand, we are able to take various precautionary measures, and health management is much improved. Health apps and wearables are supporting much for individuals to take care of their health. That is what these are some of the healthcare apps and wearables advantages. Types of healthcare available. Many of us know for available healthcare apps for fitness. We have My Fitness app, Strava, Fitbit. Diet, for diet and nutrition apps are available, like Lucid, Yazi. Chronic disease management exam are available. Examples are Carb Manager, Blue Star. Mental health wellness apps are available. Examples are Headspace and Calm. These are the some of the popular apps available for monitoring health activities. For sleep tracking, we have apps like Sleep Cycles, Pillows. For telemedicine virtual applications, the apps are available like Teledoc. Wellness offers telehealth services for medical, mental health and wellness needs. Medication management apps are available. For example, Medisafe, Pillboxy, or the medication management of apps. Wearable health devices, fitness tracks, all these things we have discussed. Continuous glucose monitors, all these things already we have. And coming to the benefit of health app and wearables, as we said, empowerment and engagement, personalized health insights, improved chronic disease management, better preventive care is possible, real-time monitoring and remote health is nowadays used. Enhanced communication with the healthcare providers are possible because of the healthcare apps, right? And increased motivation. The patients are increased to increase or what is it, to take care of the health, right? Because of the availability apps with various kind of advices, various kind of motivations, right? The things are moved right, towards positive side. Coming to the challenges of healthcare apps and wearables, data privacy. When we use various apps and various wireless technologies, the again the problem about data privacy and security comes. And the accuracy and reliability of such a data, that they can collect inaccurable data and give advices, and it will it will automatically lead to complications in the medical treatment. Adoption and integration. It is sometimes right very difficult to adopt, right, and integrate with other healthcare applications. Battery life and medicine maintenance is very important. This energy side and maintenance, energy side is to be considered, because we are still right using the things for lifelong or for many hours. It's very important to take care of the battery life used in kind of application devices which are which are used in wearables. For example, pacemakers fitted in a patient, or continuous glucose monitors, or some kind of heart rate monitors. All these things need continuous the long life batteries. These batteries are very are must be much durable. These are the main challenges in wearables and apps. Now, coming to the application of artificial intelligence and machine learning, already we have discussed about it in various applications, like decision making, disease conditions, and showing that and the things more accurately, or right, either in image or analyzing the data. The AI and ML uses very very good algorithms, and give predictions to accurate to high level accuracy. The patient portals, right, because every patient has his own portal, they can see all the data. It's a very important thing. Big data, as we have discussed, big data and analytics, right, creates a big shift in many areas. Similar to that in healthcare also, in healthcare sector also, it is showing a big shift, right, in providing the facilities. Blockchain and for healthcare data and security. Now you can see that the blockchain technology ensures the patient's healthcare, right, and it is one of the best technology. Now, come all these things we have discussed about the electronics record, healthcare, healthcare information exchange. Now, coming to the IoT, before going to the some of the devices used in medical devices, we'll see what is an IoT. We are not going to see much about IoTs. And IoT, you know that it is divided into 4 layers. Let's see the top layer is a perception layer, where we use the devices, normal devices we use, like cameras, robot, sensors, all these things. And coming to the technology side, transport layer, the thing is that the top one is everybody is able to see, and the second one is a little more, right, technological oriented, routing, Wi-Fi, Bluetooth, transmission, the transmission towers. These are the communication technologies. And the third one is right from the top. Third one is web services, data centers, and clouds. So completely the storage sites and processing centers. And the bottommost one is the application layer, where the the device is directly connected on the patient. It may be a smart health app, watches, and smart home, or smart cities, or smart grid. So these are the physical that applications. So what the need the people, what the service shown to the society is shown in the application layer. That's what we say, it is an application. So services, so before seeing all these things, these are the protocols. See, actually a protocol is nothing but a set of rules for how to in terms of network, how to make devices to communicate among themselves. Coming to the IoT, the protocols are used to give guidelines, or the rules, not guidelines. It's a rule, right, of how various things, how a camera is to communicate to the router, or how a robot is to communicate, how a router should send the data to the processing center, how the processing center should send the data to the application layer. So all these things, so the total application is divided into 4 layers. So as a four set of rules, right? A composite, right, form is divided into four. This one, depending on the nature of the things which happens, right? So that's a four level of layers for coming to the comparison. Already in a computer we have a TCP IP model. Comparing the TCP IP model with the IoT protocols. For IO Internet of Things, we have separate protocols for message, MQTT message, for transferring messages, COAP, AMQP, right, XMPP, HTTP protocols, and that is available in the top layer. And coming next one is similar to UDP and TCP available in the network, and the third one is also in the lower from the top. The third one is IP version 6, IP version 4, low low WP band, RPL, and the bottom one is a device technology. It is nothing but IEEE 802. Whether it is a Wi-Fi or it is a Ethernet, right, or GSM, all these things are given in the bottom layer. So this is about the IoT protocol, right, architecture. Now coming to the definition of IoT, the IOMT. So IOMT is nothing but Internet of Medical Things, which we know that it refers to the network of medical devices and healthcare applications that are connected to the internet, enabling them to collect, share, and analyze data in real time. So it is here in the Internet of Medical Things. Instead of discussing about the common devices which we use in IoT, we discuss about the connection of medical devices to the internet. So this includes devices like wearable healthcare monitors, smart medical equipment, and connected diagnostic tools. So now the IOMT allows better patient monitoring, improved diagnosis, and more efficient healthcare management. Since time is running out, I will just skip a few things and go. Coming to the types of IOMT devices for remote monitoring, in-home IOMT, public home, in-home IOMT. You can see that it is a medical emergency response system, oximeter, sleep trackers. It is in-home IOMT. The IOMT devices used in home. Public IOMT devices, point of care, vendor machines. These are the public IOMT. Wearable IOMT, the Internet of Medical Things. So like smart watches, fitness trackers, headsets, smart technology clothing, all these things. Coming to in-hospital IOMT, smart beds, intelligence, emergency systems, electronic bracelets, and body signal collecting gadgets. These are the right in-hospital IOMT. So the four levels of the IOMT devices for remote monitoring are possible. Now coming to the IOMT architecture, now you can see that it is divided into three sections. One side you can see, then the bottom side, the right, left bottom shows the sensors where the patient is connected with the various sensors, right? Or either patient has a smart watches or contactless patient data gathering devices. It can be a medical device or emergency services. Anything can be, right? Collect the data can be collected from by any of the devices and can be sent through internet to one particular, right, this right, repositories, right. So what you have here is IOMT applications, so where medical records, nutrition regimes, medical libraries, drug information systems, all these things can have send information to the healthcare experts, and the healthcare experts to see all the data, right. The information can flow to the laboratories, can go to the biotech or medical staff or any kind of medical inventory. It can be taken into, right, and the data can be analyzed. These are the, so already this diagram, so it's common. Now coming to the very important technological thing about the IOMTs, we use various technologies for IOMT: Zigbee technology, Bluetooth, low energy, IEEE 802 0.156 UWB Wi-Fi, low power Wi-Fi. So this, and each technology has its own standard and network topology, as well as the distance over which can be transmitted, the frequency at which these signals, this data can be transmitted by using this technology, and the bitrate also is given at the level extreme right. Right, these are the various technologies, right, available for IOMT. And coming to the, as I said, the Bluetooth, RFID, NFC, Bluetooth, 6GB and beyond can be connected to the Internet of Things through the smartphones, monitoring. The monitoring of vitals, sensors can be used for various data collections, smart wearables, and remote consultation can be combined to the Internet of Things by using these technologies, communication technologies available. Now, the other aspect of this one is you can see the healthcare staff is available one place, and the ISP network is supporting for healthcare, and the satellite communication is used for healthcare, and e-health infrastructure is available in somewhere else. So the data can be used, transmitted from one sector to another sector through the satellite, through the tower communications by using. So a series of technologies are used one after the other for exchanging data from one place to another place. Coming to the advantages of the Internet of Things, that IOMT, improved patient monitoring, remote patient care, and enhanced decision making. Examples of connected wearables, as we have discussed, wearables, right, medical devices, wearables, implantable devices, remote monitoring devices, home and dialysis systems, image devices are some of the examples. Benefits of connected Internet medical devices, improved patient conditions, as we have discussed all these things. Advantages of Internet of medical devices. So again, it is okay. We not to. Now coming to the wearables, it's already we know that smart watches and health bands are used for this, for measuring various data, right, from the patient, like calories burned and sleep patterns can be measured, heart rate can be measured. These are the vital signs, right, which represent the condition of the patient. There are some biosignals, biosensor, which measure the vitals. Signals, right, like some kind of thing, blood pressure monitors can continuously or periodically track blood pressures, and thermometers can smart thermometers can track body temperatures and can send data to the healthcare providers. So these are the some of the, right, technologies which is are available for better healthcare management. Glucose monitors can, it's one such a things which are commonly used. And coming to the measurement of bioelectric potentials, like ECG and EMG, 1020 systems for EEG, and 12 ECG leads can be connected, and these are the systems available. The patient ECG waveform, right, changes in the ECG waveform, the heart rate variations can be analyzed. Coming to the respirations, right, the respiration of the rate of the patients and breathing conditions of the patient, all these things are being detected. They can be connected, right, to the amplifiers, and it can be sent to the physician through Bluetooth or wireless connections. And coming to the ECG sensors, we can connect ECG sensors. We have discussed, sir, respiratory sensors and smart right, patches, implantable sensors like pacemakers, neurotest stimulators can be used. Right, these are the some of the. Coming to the other important one is smart diabetic management, where insulin pumps continuously glucose monitors. So the for diabetic patients it can be used. So various things. So this is about one such a monitor, right, which measures when a patient or a person is running or walking, the devices can measure the data and send it to the healthcare providers to monitor the patient conditions or person's conditions. Challenges are data security, privacy, interoperability, reimbursement models, and digital libraries. For this, we have a different for standards. Now, the feature of these medical devices, artificial intelligence, advanced sensors, wearables, and healthcare integrations, or the integrations for everyone is going to take place. So this is the condition where you see all the devices, so everything is possible. So because of the connectivity, interoperability, and the communication, and the hardware technology, software technology, programming, and AI and VR, machine learning, everything, right, supports for better management of healthcare. Common scenarios for healthcare exchanges. One is patient transfer the data. For example, patient transfer the data. Lab results are shared. Referral informations can be shared. These are the things which the data can be shared from one place to another place. Now, to address all these things, we have one kind of guidelines. We say that it's a standard, right? The standard is nothing but a generic guidelines for doing any activity, either for making or making a technology, whether it is a hardware technology or software technology, whether if it is for product or process, right? Process is nothing but a software side, product is nothing but a device. So that is either for this or for treatment in hospital, how the hospital is to be maintained, how the treatments to be given, what data is to be collected from patient. For all these things, the organizations, the world, or the WHO clearly specifies what is to be done. A document published by the census and approved by a recognized body is a standard. The standard provides rules, regular guidelines, or characteristics of for activities of any particular result. In general, a standard can be as a set of rules for ensuring optimum quality. And then the standard will have its own. We will define about the life cycle: development, development, adoption, market recognition, utilization, and adherence. So these are the cycles for any particular right process. Coming to the standards, as I said, the process standards and product standards, right? Both are needed, right, for better service provider. Service, and as well as the best service and the genuine service. Medical standards developing, there are very many number of medical standard international organizations like ISO and IEC, International Electrochemical, right? These are managed. These are the managed by members of various countries. There are standards like BSI, NSI, the standards maintained by India, America, Japan, right? European nations. They're like standards are available. Standards can be maintained or can be created, maintained by associations like IEEE, AAMI, ASTM, and NEMA. These are the associations, technical associations created standards. This it won't be an exaggerated statement if we said that the standard is a way of life. So it is a way of life that is to be followed and adopted. Every inch of any field is governed by either a national or international standard. So in healthcare also the same thing is applied. Coming to the medical device standards, we have various standards like ISO standards, IEC standards, generic standards are available. Coming to the software standards, IEC 62304 ensures quality throughout the software development like cycle process in healthcare. HGML, HL7, and ICOM standards. If you want to talk about HL7 and much, but time is not sufficient. And we have a generalized standard generalized markup language, right? Forms, right? The basis for the several widely accepted language, right? For interchange of documents from one place to another place through the internet. That's a standard. According to Riordan, the standards are set of particular concerns to physicians and other professionals in healthcare services who daily make critically important decisions regarding the utilization of many new devices and diagnostic process products offered in medical products. The Kanpur states that there are thousands of standards and guidelines covering the healthcare for facilitating codified approach. We are also going to show some of the codifications, right? How to create a unified ID, right? For patient or doctors and all these things. According to the uh, Anagostek 2002 encourage the standards encourage competition, enhance effectiveness of applications, reduce development cost, and drive down prices. It's very important. It's a very important points. These are the important why because of the standards in communication technology in the computer technology, right? We are able to get right any accessories, any compatible. Things from market to make it to work with the existing things. Coming to the limitations, acquisition, storage, and retrieval processing, decision making and transmission is another important thing regarding the healthcare standards. Coming to the as I said, the patient unique ID, because there are a lot of researches have been done. We have to initially long back we have done certain things. We have taken effort to create a unique ID format for the patient. Right, this is having this kind of characters from person's characters. We have taken first four character, middle four character, last four character, gender, date of birth, time, chip code, and country code, and we created a patient ID. See, for this patient ID is generated. Right, you can see this all these things. This unique patient ID has 34 alphanumeric characters. So this patient ID is so we can create a patient ID like this. This one example of patient ID. There is another example of physician ID. The same thing. So the unique ID patient the right can have a right the patient's the doctor's unique ID 34 character. His specialty 2 character for his specialty, 8 character for date of registration of his profession, and five numerals, not five numerals for registration numbers. All these things can be used as a patient, the doctor, physician's ID, unique ID. Like this, we can have a laboratory IDs with the 25 numerals, right? With the various types of what type of laboratory it is, name of the laboratory, type of laboratory, year of registration, laboratory register number, zip code, country code. All these things can be assigned with some numerals, and the laboratory ID can be created. So with right this laboratory ID. Similarly, we can have a various IDs for 31 alphanumeric character ID for hospitals, right? Naming convention for hospitals we have created hospital ID, and we have created biochemical for one particular laboratory, right? We have created ID with the 53 alphanumeric characters, and for this is the thing which we have result we have got. The lab report for the report we have 53 numeral ID has been created, and this is an example of how we created ID, and by using that ID how the process has been completed. For image data, where 64 alphanumeric characters were used for to create a image ID. So the image ID consists, so you can see that for technical code, directional code, anatomical codes, biological codes, all these things, right, we use, and there the ID was created, generic ID was generated, and the image is 64-bit ID. So the numerals ID was designed, and design development of file. See, this is about the ID created. Coming to the design development of files, where the any data is to be stored in the file format. There are some open standard files which are available. The open standard files will encourage competition, improve the effectiveness of application, reduce development cost, drive down the prices. Because it is commonly available, the cost will automatically come down. The biomedical signal data files are used in testing, design, and design of healthcare information software, scientific research in drug trials and the healthcare. The standardization of biosignal data files facilitates international and multi-center collaboration and multiple use of the same data. It is a statement by Lola 97. So by using this, there's many standards have been created. There are three commonly available open file format, right, which are a European data format, extensible biosignal file format, MIT format, Massachusetts Institute of Technology format. The MIT format, you can see arrhythmia signal, the storage, data storage, and the extensible is used for pathological, experimental pathological. It was designed in the University of Erlangen, Nuremberg, Germany. And these are some of the data which are when the European data format was used, is being used EEG measurement, EMG measurement, and EOG measurement, body temperatures. This is the file format of EDF file. Any file will have a record, right? A header record and data record. The header record has a file header and signal header, and all these fields have been given. We don't have. So a number of, say for example, if we have a header represented by 256. Suppose there are two signal pins. The 256 into 2, the number of headers, right, signal headers will be available. And coming to the highest abstraction level of, see, when you have a different type of data formats, these data formats can be converted into one unified format that is called a file exchange format. A file exchange format will convert the any data coming as an input to a common format. So that is called a file exchange format. So again, file exchange format will have a different section like preamble, session, archive sections. And like, see, this file exchange format it is available as a standard, right, guidelines. By using that, we can design a file exchange format. It is available in the W. So it's such a European data format. This is a file viewer, and the previous one was the data format, and now this is the file exchange converted format. So like this, we have another format, MIT format. The file. This is the format for the file exchange format, from MIT format to file exchange format. Conversion from raw data. Raw data can be converted from converted to file exchange format. So this we created, and it was shown. Now coming to the ones. This is about the data record. Now there is another standard called health level 7. It means that the 7 indicates the seventh layer in OSI model, that is application layer. The HL indicates a health level. So health level 7, it means that it is an application protocol, where it is the protocol is written to show the data for the user interaction. So now this particular HL7 has a format. You can see in the top and the bottom of the slide, you can see a message, right? A message is a message, and you can see that some kind of symbols. So the vertical pipeline shows the field separator. So this message is divided into different sections, different subfields. First one is a field separator. Second one is a component separator. In the field, there are different components which are available. The components can be separated by using ampersand. Another character subcomponent. For subcomponent separation, there is a one symbol. Coming to the field separation, there is another tilde symbol, and you have a slash symbol, escape character. So now the HL7 segment is divided into data, and the data is divided into component is divided into subcomponent. So these are the 4 level of abstractions: level 1 to level 2, level 3, and level 4. So now coming to the clear example of how this one is used. Listen here. Now we can see that HL7, this is a HL7 format available, right? Various persons have come right now. The first is the various segments are available. Messages, we say that is a message segments, and we can see that the compound separated field, and see various. I will show the example. And here itself we can show the first MSH, then the field, the various subfields and generators, then information transmission, the source, then destinations, and the type of message, and all these things are given. It is given one after the other here in this. Now this is message 1, field separator. Then encoding characters. There are four characters we have seen. Then sending application, right? The next message is sending application in a message segment. So these are the the messages, the characters which are right, placed between two vertical lines. So they are placed between two. So it means there are 14 verticals. Some are mandatory, required, some are not required, right? So here you can see first field separator, then encoding characters, sending applications. For example, MIS, medical information system, is sending application, or hospital information sending application, then sending application, followed by receiving facility, whether it is a laboratory information system or doctor. Then receiving application, what application is then receiving facility, the date and time of messages, and security measures, all the message types, message control ID, processing ID, version ID, sequence number, all these things are are arranged here. So one after the other, some fields are required, some fields are optional. And this is one such a table we have created for various, for example, ACK means acknowledgement, ADR means and the ADT, admission, discharge, and transfer response. Like that, we have a different right segments. And in one particular, if you click one particular segment, you can see various process like A01 states admit visit notification, A02 transfer patient. These are the numbers, standard numbers assigned for any particular parameter when naming. And this is what is different type of message. Say suppose for listen. Yes, if you see the first one, it is a table. If we click one table like ADT, what is it? So within for 10 minutes, I will complete, please. Then if we take AD2 or AD2, A02, then you can see the second column, message header, message, right? And message, even personal identification, personal next to kin, person visit, patient visit one, patient visit two, like that we have a different, right, namings. And if you click one in this, then you can see various, so like that we can go on visiting, right, visiting one table after another table, then you can finally see what the end place, the end event which takes place. This is one such a table, attribute table we have created, right, for HL7 message. Time is not available much, so we will skip all this. One such a information system, I said that ADT system we created, where we have processed HL7 message, where you can see the various front office, doctors, details, patient details, and the HL7. So HL7 is one which makes interoperable. It maintains or ensures interoperable among various entities like ADT, LIS, MIS, or with the MIS or ADT in another organization. So coming to the segments, as we have discussed, various segments we can enter. So it is as it is application level, right? It is measured as it is given as a what is it boxes. So the thing is they have to enter it, and it will be combined together. It will be encrypted and sent through the medium. Right, it can be sent through by using the technologies safely, though nobody can retrieve the data, right, without any permission. That is on. Now, can the HL7 message, how as we have discussed various this generation of HL7 message based on the data we give. So this is up to. So here, coming to the code, another code is laboratory observations information system. Again, it is a code for every these things. We have a code here for example, R wave, the duration, lead one, lead two. We have a line code. Line code is available in WHRO, right, from which we can take, and so a table was created. This is one such things. This elaborate information systems, and we used IRMA, image retrieval in medical applications. So where we have given a naming convention for image data. So this is about the image data, and this is about the lab image. See one example. We have this is about the image data. So we have given a IRMA code, and this IRMA code was generated. If you see the right side of this particular slide, right side figure with fingers skeleton, right? Then you can see that code in the top, right, and followed by this image convention, naming convention. So this is one thing. ICD-10 is also there for codifications. So here we have a symptoms, a number of symptoms. Each symptoms, right? Then based on the number of systems, symptoms we get. This is expert system we have discussed. We will give the symptoms about the patients, and the expert system, right? By using fuzzy logic, will give you the what is the suggested disease. For example, common cold, sneezing, sneezing. So you'll give a weight, right, from 0 to 1, right? 0 means nothing, 0.5 means average, 0.7 means, right, it is more than average, 25 means less than average. So based on the weightage, various weightage we give, right? It is one kind of AI, artificial intelligence system, right? Which we designed. So this is the type thing which we are. So everything is in the system. Only we have to click it, right? Based when the patient comes and we inquire the patient and ask him and fill the data. It will give the type of disease the patient has come with. So this is about the display, right? Finally, so this is what we have given some kind of values for each symptoms, and it has given a disease as a common cold. This is about that isolated business. Now we see that the Alexa is a one thing which gives a lot of advices to the doctors and a lot of health advisory right? That the AI tools, define interface purposes and goals, functional design, and various things are given by Alexa. Right, so that is now we don't. Please, before winding up, I have one software application that is Think Speak. Just within 2 minutes, I will complete Think Speak. I we have a we have the previous discussion. Dr. Kulandevel sir has given one application. He has shown the Tinker applications. Now we'll see the Think Speak application. How Think Speak will support the IoT applications. Share Think Speak in the share. I'll just open and show how many of you may know it. Few may be knowing. It is very important for people who are working with the projects. The ThinkSpeak is one such a thing which we can use with IoT and collect data from the IoT devices and connect to the ThinkSpeak, and we can see display it. This is ThinkSpeak applications. Anyone who wants to start with the ThinkSpeak application, sit- so now they can open, right? You can enter your email. Under my email, my password. I can give my already if I have signed in, right? I can give my password. Now this is the ThinkSpeak, right? App where we can create your own channel. For creating your own channel, what you can type create a new channel. My channel already. You can create a new channel. Yes, to create a new channel, you can give a, for example, I give a temperature. Just I wrote it, and I just recording. I put recording. Then I create field. So various, suppose I want to create fields, I create field. I have created for three fields I have created. After creating fields, what we can do is we can scroll down and finally there will be a option for storage. You can save the channel. Channel will be saved. Once the channel is saved, what you can do is this is the setting our channel. Once if we create the channel, then you can go for API where you can use API. The API will generate the application protocol interface. This here you can see the get data. Here you have a API for get data, read data. The various channels are API keys are available. So you can copy this key to that particular the system which we are using. Definitely what that you can get the information. So this API key where you the place where you fix this API key from get, right, will be connected to this thing speaker. The data can be collected from there and it will come to your channel, and we have created a field that it will be displayed in the field. The field what you can do is here your channel setting. Yes, yes, your channels. If you go to my channel, if we click it, yes, the data will be stored, right, displayed in the channel. What you can do is you can click the pen button where you can program, you can design your field, the graph type. The graph will be displayed. So here you can choose a title, x-axis, y-axis, and the color of the graph. All these things can be planned here. So ThinkSpeak is a very important high speed the IoT application platform where we can use it. And if any doubt regarding this, if you want, you can contact us. We will definitely do some kind of support. Thank you very much. So at this time is running out because the previous professor has also taken half an hour extra. Right now it is time. So we are very thankful for all the participants who have patiently listened and actively participated in all the 5 days. And we request all the participants to come tomorrow also by 2 o'clock. And we expect all participants will get a certificate without any issue. And we hope that we will have a continuous collaboration and cooperation. It is a starting of collaboration, cooperation. Like that only we have traveled virtually across all the states, and we are very proud to have participants from various states. We thank you very much for this opportunity. Thank you for active listening. Thank you all. Thank you. Good night to all. Thank you. Any doubt you can post to me or contact my number. Thank you all. For photo.
Thank you, sir. Thank you, sir. Thank you for your valuable information. Actually, regarding the e-health and IoT, your valuable talk about the e-health and IoT is really useful, sir. Particularly the future of M-health by the integration of the AI and the ML is going to be the emerging trends now. Types of e-health is very informative, and also the exchanging models which you delivered is really fantastic. You also give a lot of e-health applications like Strava, Fitbit, Lossit, Crab Manager, Blue Star. These informations are really useful, sir. Thank you, sir. Thank you for your excellent lecture, sir. Thank you so much. Dear participants, thank you for your active participation this late night. On behalf of St. Joseph College of Engineering, once again we will extend the heartfelt thank to our speaker, Dr. P. Chinnaya, sir, Professor, Department of Electronics and Communication Engineering, St. Joseph College of Engineering, Sri Peramadur, and also the coordinator of this AICT sponsored 6 days Atal FTP. I request all the participants to switch on your camera for the photo session. Thank you all. Thank you, participants. Thank you, everyone. Have a great night. Thank you. Regarding tomorrow's session, tomorrow shortly at 2 p.m. session 11 is going to start, and by 3:30 p.m. session 12, and by 5 o'clock the last session, session 13. After that, we have the validatory function from 6:30 p.m. to 7 p.m. And from the 7 to 8 p.m., dear participants, you have to attend the exam. Thank you. Thank you all. The further information will communicate it through the WhatsApp group. Thank you all. Thank you.